Hi everyone, welcome to my channel. So let's get started with second part of this training. I have the PGSuper open in my computer. So once you open this, you go to File, click on New if you want to create some new project, and this window will pop up. So let's say uh, you have like eye girders, you have eye girders to be designed, or there if you have box girders to be designed. So these are all Texas standard girders. um, let's so if you go to PGSuper project templates here, you will find uh, like slab girders, U girders, white flange girders. These are all um, WASTAT, the Washington Department of Transportation standard girders. So I will show you how you can do uh, some standard girders design in for WASTAT. So let's select white flange 66G just for initialization, which you can edit later. So once you click OK, it will generate a random bridge, like a bridge it will create that is not your intended design, but you can edit. After you do that, this project properties will pop up, and you can type your bridge name, your bridge ID, your job number, your engineer which you are which designing, the company information, and any comments that is on um, you need to you would like to add. Click OK. So see this these are the this is the bridge that is auto generated by uh, the PGSuper, which you can edit now. So let me before that, before we dive into detail of how you can do step by step, let me show you the uh, graphical user interface. So here the first part you can go is on the edit. So you can edit, you can go to edit, and like the first thing on your bridge, you should always give the information is about the alignment. It's step by step, so it's you go to alignment, you go to the there is a horizontal profile you can put. You can give the name of the profile, you can give the initial direction as per your the bridge geometry, horizontal geometry, and your profile, your vertical curve information, and your super elevation information on this roadway cross section here. So I'm just showing the graphical user interface, so we'll do an example later. So not only that, you don't need to go edit and go to alignment. You can also click on this blue button here. So if you double click on this one, this will directly pop up. You don't need to go to edit. So this is the first part. So then you have the second part, which is the bridge. So let's move to the next portion, which is the bridge portion. So if you click on the bridge, the first part you will see is bridge line offset. So bridge line offset is basically so it's a reference line about which this layout line is to be placed. So for example, in some cases, in this auto-generated example, uh, the uh, the deck, the crown of the deck is centered just at the middle. However, in some cases, you might have some geometry where the crown might be somewhere here or somewhere here. You know, if you need to adjust that, you can always use this one, and there is a description to guide you how to use it. So you can either use positive or negative value, which indicates the positive value. As you can see here, the positive sign value indicates bridge line is located to the right of the alignment, and negative value means to the left of the alignment. So let's say I use 2 feet, which indicates that the bridge line will be 2 feet right to the right of the alignment. So if I click 2 feet, then this bridge line which you created, it will be 2 feet from the alignment, and it is right in the to the right of the alignment. And as you can see, the slope is the crown is now at this location. So if you need to change that, you can always use this, which is very useful. And another thing is, if you need to, there one very good feature of PGSuper is that you can undo any changes anytime. So either you can do go to edit or undo edit brace, which it will lead to undoing what you had done, or there is another option, undo or redo. So let me go to the redo part. So it will redo the part you had done. And another is Control Z, like you do in other portions. Let's say I in my mouse in my keyboard, I click Control and Z. It will go back to what I had before. So this is regarding breeze. So also, like I showed previously for the alignment, you don't need to go to edit and breeze. You can also do it by clicking on this line. So if you click on this line, it will bring up directly this tab. So we discussed about this part. So let's go to gutter type. Our gutter type, you can choose any what your gutter type is. So if it is like I-beam or deck balti or any other voided slab or any other kind of structure, and gutter name, you can give it to gutter name. I will explain you later how you can change this to make your own, like to make some other kind of gutter section. And you can choose like whether to use the same gutter type for all gutters or not by checking or unchecking this. So let me go back to here. So you can vary your number of gutters from here, like 4, 5, 6, 7, or like anything, and use the same number of gutters in all span. This option you can also edit this one. So and here is the location of the gutter working points, which is the top center line of gutters. This means all the dimensions that are being measured, they are being measured with respect to the top of the uh, top center line of the girders. And it has other option of the bottom center line of the girders, which they will measure with respect to the bottom of the girders. This is as per in washed practice, they generally use the top center line, and the bottom center line is sometimes you can use when like when you have girder sloping, like there is a sloping part and the top and bottom values, they are different, so you can use either of them. And then you have the spacing type. You can use like same spacing for all girders, or it's unique spacing for each girder. You can choose this. We'll get back to it in an example later. So, and this girder spacing, you can, when you have the same spacing, you can use the girder spacing. Then look at girders, center line of the girder. As you can see here, the center line of the girder, uh, 0 feet. We have currently 0 feet from the bridge line, or you can either choose alignment or bridge line. Bridge line is the one we discussed previously by giving some value here. So you can choose either alignment or bridge line. With respect to that, it will give you the center line of the look at the center line of the girder, and they are being, and this offset is being measured normal to the alignment at abutment or pier line. So abutment or pier line is this line. So abutment is here, and the abutment line would be here, this one. And you have other option, measured at and along the abutment line, measured normal to. So this this is this comes into play especially when you have skewed bridges. So when you have skewed bridges, you have, when this is skewed, uh, the the normal length and along the abutment length, they are not the same. So this comes into play when you generally have skewed bridges, and the Gordon orientation is plumb with the gravity, and the deck type you can choose, like generally we have composite cast in place deck, this which is like default one here. So this is part of the general part, and you can go to layout. So in this is the part when you use the station. uh, if you are just designing the preliminary, you don't need to give the station. You can just give an arbitrary station based on your length of the bridge. And here it says bridge starts at abutment 1 or abutment 2. You can just like abutment or pier 1, and it's insert pier or abutment. So this is a single span bridge, so it will just start at abutment 1 and end up another abutment. So, and here you can give the station of the abutment 1, this one. I'll show you how different ways how we can do it. So you can start the abutment 1 and give the orientation, whether normal means it is like zero skew. If you have some skew, you can just give some value here, uh, either positive or negative. Let's say I give positive 25 on both sides. It will be like skewed, and this abutment will be skewed. I just undo the changes. So let me go back to here again, and this is the orientation. You can either, here is the guidance how you can use the orientation. Like you can either use the in uh, degree, minute, second, or put the values, or the northing sting, the the degree, minute, second in northwest or northeast, southwest, those kind of things. And then there is another portion which you can see here is 130 feet, which is now the current the span length. You can edit here by giving the span length here. And uh, let me not go to other portions now. I'll just go to step by step. So you can just make changes here, and if you need to add any span, if it is continuous bridge, you can insert here, like span length here and span length of so after this abutment to how much span length is there, let's say 120 feet, and it starts at abutment 2, or it starts before abutment 2. You can give any option. So let me show you, like after abutment 2. So if I go do there, then this becomes the pier 2. So, and let me see what happened here. Let me go here, layout. So 10 to 1 plus 30 pier 2, this is 130, then pier 2 abutment 3. Let me see what the here it is showing. Yeah, in the profile it is showing. Let me zoom out a bit. Oh, okay. So view spans, now you can see like the whole bridge here, because I was seeing only view spans 1 to 2. I was just doing view spans 1 to 1, so it was only showing me only one span, where I can do like two spans looking at the same time. So let me revert it back to what we had originally. So in this layout, that's how we can change it. And there is other option of layout by span lengths. You can give the any length, span by span. So span 1 this length, span 2 this length, some kind this kind of arrangement. You can do it, and you can play around, in different ways. And you can orient the piers by giving whether it is normal or by giving the giving the skew values, you know, in degree, minute, or second, or in uh, in numbers. So you can play around this to give how to show uh, how your bridge is oriented, or the piers, the abutments are oriented. And then there is another option of railing system here. So railing system, it's a barrier. So basically, these are the barriers they are being used here. These are the barriers they are being used here, and you have an option to choose the left railing system, right railing system. So either both of them might be same, or both of them might be different. So in case there you have, let's say, pedestrian barrier on one side and no any pedestrian barrier on the other side, you can choose between these two, you know. So you can choose any shape from here, and you can choose whether there is a sidewalk, or sidewalk on which side has a sidewalk. So you can give the width, back face, the back depth, the face depth, the weight of the concrete, the unit weight, the strength of the concrete, and in more properties you can give whether it is a lightweight concrete or normal weight concrete, this kind of values for the concrete and the aggregate values, you know. So these are very useful when you have sidewalk. Let's say like now if you have sidewalk, let's say I give a random like this auto generated values, it will give me a sidewalk here. And another very good feature of this PGSuper is you can slide this bar to see the section at any location. So you can slide this bar. So, and also you can double click on this. Let's say I double click on your left mouse, on your left part of the mouse, you double click here, and let's say you want to see the station at let's say 100. It will oh sorry, 1 plus 0 plus let's say 0 plus 70.00, it will take it to 70. So as you can see here, it will say section at station 0 plus 70, normal to the alignment. This is normal to the alignment. And so this is that portion. So sidewalk is here, if you can see. I'll show you other ways to play around this one. And one thing you will always you should always try to make sure is this dimensions are as per your plans. So when you are generating, it will be like you will be refining again, editing, refining. That's how you get back to your final model. Let me go back to uh, the railing system, and let me remove this sidewalk for now. And then there is another option of deck materials and geometry, deck materials, deck geometry and materials. So this is the portion where you will input your deck information. So gross depth, let's say you have your gross depth is 8 inch, and sometimes the gross depth sometimes you can have like some sacrificial depth of 0.5 inches, and you can just you can just mention that here over here, like what is the sacrificial depth, whether it is 0.5 inch or 1 inch. And uh, and it will deduct this value from the gross depth to calculate the section properties. And your overhang depth, let's say 8 inch and 8 inch, you can give the values that you have all different options, whether to taper the overhang to the top of the flange, or constant depth overhang, or taper overhang to the bottom of the flange. This various option you can use as per your bridge configuration. And on geometry, these are kind of standard. It's per like as per WASTA, the fillet, the minimum fillet you should have is 0.75 inch for the eye girders. So it can be 0 inch for voided slab, and this you need to check your specification as per your DOT to make sure what is this value, minimum value you should be using. And you can choose the horn shape, whether it is filleted corners or square corners. uh, you know you can just choose as per a requirement. And this another important part of this another important part of this PGSuper is a dimension. So a dimension is nothing but it's the sum of deck thickness and haunch. So let's say I have 11-inch a dimension. So my gross depth of the deck is 8 inches. So my haunch depth is 3 inches. So this haunch depth I am using is 3 inches, and this a dimension is at the piers. It is defined at the piers. So or like in piers or abutments, let's say at the end, and this value is maximum at the end, and it will just follow a parabolic shape. In actual, it will just follow a parabolic shape uh, to to calculate the section properties or weight. And I'll show you later how you can play around with those, because you can either assume this as constant throughout the bridge, or you can vary as a parabola. And you have a wearing surface option. You can choose like sacrificial depth, overlay, or future overlay, whichever is per your project requirement, and give the overlay weight in KSF or overlay depth and the unit weight. It will automatically calculate. And this one is just for load rating criteria. You can just give the value as per your inspection, or when you are designing new bridge. And another important thing here is the offset. So so let's say you have, so as you see here, the station is from here. It's basically like it's basically uh, the deck, the total uh, deck span. So how much it covers. So from station 1, from station 0 plus 0, 0.00, which starts, and if you don't give anything, it will just get it to the end of the bridge, until you give any breakpoints here. And this is measured from bridge line or alignment. You can give either of them. If you have bridge line, if you feel comfortable with bridge line, use bridge line, or if you feel comfortable with alignment, you can use alignment, and use either of these, and left offset and right offset. So so on the left, some if it's per your roadway section, you might have, let's say, left offset of 30 feet and right offset of 30 feet. It will automatically increase the length, increase the deck width. So based on that, you can increase the number of girders here. So based on that, you can go to edit. You can either go to edit, or you can just go double click here and increase your, like, let's say, number of girders to accommodate the total roadway section. Let's say girders number 7, and they will just get rearranged. And you can either increase the spacing to, let's say, 8, and you can have like this kind of arrangement. So it's like, playing around um, to get to your final desired cross section. And let me go here again to take geometry and materials. And here you can see normal weight concrete, the value of concrete, the the strength of the concrete which is being used. So that you can put the value here which is being used in your project. So here it is 4 KSI default, and it will auto compute the modulus of elasticity of the concrete. Or you can either, if you uncheck it, if you check it, you can give your value. It's basically calculated as per ASTO. And if you uncheck it, it will automatically compute. Let's say I have like 5 KSI. It will just automatically compute that. And if I have 4 KSI, it will just automatically compute that. And you also have option of more properties which you can tweak your values, like whether it is lightweight concrete or normal weight concrete, strength, the unit weight, all these kind of things which I showed you during the sidewalk. So these are all the part for the deck. So here you can also define deck reinforcement. Now let's move on to deck reinforcement portion. So here you can choose your top and bottom mat of the deck reinforcement. So you can choose the grade of the steel, the rebar here. Basically what happens is PGSuper generally doesn't, PGSuper does not design the deck for you. You have to design your deck on your own separately, but for your complete modeling you can input the values here as you have as you are planning to use on your deck. So let's say the top mat cover is 2 inch, bottom mat cover 2 inch. You can tweak these values. And primary reinforcement you can choose here. So you have two options. So either you can give the top mat values like the number at some spacing, or this plus some kind of supplemental reinforcement, square inches per feet, or you can directly give like none, which means like none plus whatever you are giving per unit feet, or the area of the reinforcement per unit feet for both top mat and bottom mat. And then there is another option of supplemental reinforcement. So generally what happens is at the piers, when you have continuous span at the piers, you will need to provide some negative reinforcement, uh, negative reinforcement for at the pier locations. So you can just give your values, which let's say if you go to 8 and you have pier 1, the top mat, you can choose either pier 1 or 2, and top mat, um, the bar number, the spacing, and your left cutoff feet. Like left cutoff feet means like, let's say you have a pier here, your um, your where it is cut off, like from the pier center line and to the right cutoff length. So it is 10 feet on the to the left and 10 feet to the right. Yes, for this one. So let me remove this for now, just for information purpose, which you can use as per needed. And then there is another tab, bearings. So bearing, you need to design the bearing it's yourself outside. But one good thing about the bearing is in PGSuper is you can give your information of the bearing. Let's say you have different options, whether you have bearing data is unique along the bearing line, or is the same for the entire bridge. You can choose, generally it's the same for the entire bridge, so you can choose the same for entire bridge. The bearing shape you can choose whether it is round or rectangular, and number of bearings per grid, per girder end, sorry. um, you can choose those whatever the number you are using. And uh, so the length, you can see here in the figure, this is the length of the bearing, and this is the center line. So this is the longitudinal direction. So length is along the longitudinal direction, you should always keep in mind. Width is perpendicular to inside, in the plane inside, going inside this screen. So width is to, let's say, 12 feet. And height, this is the height, as you can see here, from bottom of the uh, top of the let's say, like you have elastomeric bearing, top of the elastomer to the bottom here. And recess height, so basically what happens is sometimes you need to punch your uh, like punch into your girder bottom, like let's say 0.5 inches inside to accommodate your bearing, to fit in the bearing, which is the value you can put here. And the recess length here, as you can see here from the drawing, and the sole plate height if it is being used. So you can just provide this for information, whatever you have used. But this also later, PGSuper can give you um, PGSuper can give you the values that can be used for bearing design. And Um, so let me click OK and go to environmental. So environmental, you don't need to like, you can just uh, it does not come much into design, but you can just check some, whether it is normal exposure or severe corrosive conditions, and you give the values of the relative humidity on here, as per your dot, how is your state, like which how much humidity they use for the design. You can just give the values here. So let me click OK. So this is all about uh, this bridge portion. So bridge portion. So I will continue the next part, giving you the overview of other tabs, other user interface in the next video. Stay tuned with me, and later we will do an example which will clear you how to use the PGSuper and how professionally how you can design a bridge, the pre-stressed girders. So this much for today. So thank you very much for bearing with me, and I will see you soon. Thank you.